Today our focus is inequalities, and we have already done some inequalities. Today we're going to incorporate the radicals in them, and then we are going to do some application problems. So when you're solving inequalities using algebra, we're still going to be isolating whatever that radical term is. And then once you isolate the radical term, you have to set the radicand greater than or equal to 0. So I asked you to think about the radicand and when does it have to be greater than or equal to 0. And then I also want you to think about why it has to be greater than or equal to 0. Chris, what do you think? Why do we have to set the radicand greater than or equal to 0? Okay, do we know what the radicand is?
Sure.
Okay, tell me what it is. Or if we're not sure, let me know. We can figure that out. Okay, so the radicand is going to be the value that's underneath your radical. Okay, so why would that have to be greater than or equal to 0? Really, if it's greater than or equal to 0, what does that mean? Yeah, which means it's what type of number? Okay, so we're saying that the radicand has to be positive. Why? Okay, and in particular, we have to think about what? Yep. So, Kim, that means that if I have an even root, I have to set the radicand greater than or equal to 0. So what if, what would be the other case? Yeah, I did say your name because you weren't paying attention to me.
Other case.
What's the other case? Am I always going to have to set the radicand greater than or equal to 0?
No, if it's like negative, it'll be less than or equal to 0. Right?
Okay, but when you have a, what type of root do you have to have it be positive?
Even.
An even root. So then the other case would have to be what type of root?
Odd.
Yep.
Yes.
So when there's an even root, maybe say thank you to Ian. When there's an even root,
you're not smooth.
Okay, because you can't take the even root of a negative number. Oh, hey, Pot. Nice to see you, Kettle. Okay, so when there's an even root, that's when it has to be greater than or equal to 0 because you can't take the even root of a negative number. And that means we don't have to do this step 2, when there's an odd root. Okay, if there is an even root, once you set the radicand greater than or equal to 0, you have to find where those two solutions overlap, just like what we did with the two cases in the LCD. So remember with the LCD inequalities, we had to do the two cases because if you multiply by a negative, the sign switches. Okay, for this, we have to consider that whatever's under the radical has to be positive so we don't get any imaginary numbers. A really nice thing to do to find the overlap is to use a number line. Okay, so the number line is going to, if you graph on the number line, you can find where those two solutions overlap. So if you have an odd root, you only have to do step 1. If you have an even root, then you're going to do step 2 and 3 with it. So example 1, we're going to solve. So this is very similar to what we did yesterday. So if I'm going to isolate the radical, Gigi, what am I going to do first to both sides? That'll be... Yes, the square it. We are going to do that. We're just going to do that second. So first, isolate the radical. So by isolating the radical, you want to move over anything that's on the outside that's either added, subtracted, or multiplied, or divided. So if I want just the radical by itself, what do I have to move over? Yes. So first I'm going to subtract the 3. So then I have the square root of 2x minus 6, which is less than or equal to 6. And then, like Gigi said, to undo the square root, we need to square both sides. So I have 2x minus 6 is less than or equal to 36. And then I can just solve this like an algebra 1 equation. Okay, and this would be something that we would do without a calculator. So x would be less than 21. Okay, with this it's a square root, so that is an even root. So if it's an even root, that's when you take the radicand and set it greater than or equal to 0. So the radicand is just the value that's underneath. So if you look at what's underneath the radical, it's 2x minus 6. That's what has to be positive. So then I'm going to move over the 6 and then divide by 2. So x is greater than or equal to 3. And then for step 3, I can use the number line to find where my two values are going to overlap. Okay, so on my number line, I have 3, and then I have 21. This is a closed circle. This is equal to, so this is going to be a closed circle. And then my overlap is right here. So now when I'm doing my solution, I can see it's in between 3 and 21. Because they're both closed circles, I am going to use the less than equal to and the greater than equal to. Okay, so 3 is less than or equal to x, which is less than or equal to 21. That is going to be our solution. Whenever your overlap is a bar like this, you are going to have one inequality. And then I want you to think about what this solution means. This is saying x is between 3 and 21. So how could I check to see if this is right?
Well, I think those numbers.
I could plug in those numbers or any numbers in between. Where?
3 and 21.
Okay, so and I can plug any number in between 3 and 21, but where am I plugging that in? And what am I looking for? I can plug that into the original inequality, and then what should happen if it's in between these? Yes, right? You should get a true statement where it's less than or equal to 9. Okay, so let's try 3. If I did 2 times 3 minus 6 plus 3, okay, I'd have 6 minus 6, which is 0. Then I'd have 3 is less than or equal to 9. Is that true? Yep. If I plugged in something that was outside of this, let's say I plugged in 2, then what should happen?
That should be false.
Should be false. Okay, so 2 minus 2 is 4. 4 minus 6 is the square root of negative 2. That would be imaginary. Okay, so then that would be false. Okay, that's how you can check to make sure this is true. All right, for B, the first thing I do is look at the root. Okay, so I can see I have an odd root. So if I have an odd root, it doesn't matter if I have a negative underneath. I can take a cube root of a negative number, right? So I can just go ahead and, Max, how would I start this one? What would I do to both sides?
Cube root.
Not cube root, but I don't think that's what you meant. You already have the cube root.
Cube.
Yep, so you're going to cube both sides. So you're going to raise each side to the power of 3. 1 to the third is 1. This will undo, so you have x plus 2. Subtract 2 from both sides. And then because you don't have to worry about the radicand, that is your final answer. Okay, this one is an even root. So whenever you have an even root, you do have to do step 2. You could even set that up right away. You're taking what's underneath, the x minus 3, and setting that greater than or equal to 0. This is always greater than or equal to 0, which means you should always have a greater than equal to somewhere in your solution. But this does not have to be greater than equal to. Sometimes it's just greater than. Okay, so I want you to finish this problem, and then once you have, will you go on to the back, read through the story problem? And then I want you to organize your important information. You might also want a highlighter, but there is a part for you to write down some of your important info. Okay, so Damien, what'd you do first to solve for this one?
Well, subtracted 2 from each side.
Good. And then after that,
Square.
good. Yep, you gotta square both sides. So you have x minus 3 is less than or equal to 9. And then you're gonna add 3. Okay, so we have these two here. So now we're going to find where they overlap. So when you put these on a number line, just make sure that you put your values in order. So from step 2, we found that x was greater than or equal to 3. We take the number that's underneath. Okay, so then everything is greater than 3, everything is less than 12. Your overlap is going to be from 3 to 12. So x is greater than or equal to 3, and then greater than or equal to 12. If you do have a situation where they don't overlap, and you've solve both of those equations, if they don't overlap, then you would have no solution that would work for that. Okay, and then other questions for me on your inequalities. All right, let's do our story problem. I'm going to give you just another few seconds to read through that if you haven't already, and then we're going to organize the information. Okay, so I need you to read through that, think about that. So you can underline, you can highlight, and then we're going to organize some of the information in step 1. And there is something special that we're going to do for step 2. All right, so when you're doing a story problem, one thing you want to look for are, what do your variables represent? Okay, that way you can organize what the problem is talking about. So right away you probably notice your equation, correct? So they are going to give you information about each variable. Okay, this is a good SAT practice problem. So they tell you that t is the time in seconds. So the time t is measured in seconds. That's what our equation is equal to. So the time t in seconds that it takes a car to travel a quarter mile when starting from a full stop can be estimated by using the formula. So you do have a lot of extra information here. It's saying that the time in seconds is how long it takes the car to travel a quarter of a mile. Okay, when you're starting from a full stop, but that's not necessarily something that you're going to plug in. Okay, so they do have the quarter mile, that is a number, but not something we're going to plug into our equation. We also know that W is going to be the weight, that's measured in pounds, and then P is the power delivered by the engine, and that's going to be measured in horsepower. If the quarter mile time for a 3,590 pound car is 13.4 seconds, and then I like to highlight my question, how much power does its engine deliver? Okay, and then we are going to be rounding to the nearest horsepower, which means we're going to be rounding to the nearest, whole number. Okay, and then again, we notice like this quarter mile time comes up. That's just associated with the time itself. So when you're organizing your information, I have to imagine the top thing on your list is going to be that equation. So we obviously have this on our paper. If you have this from your textbook, this is what you're going to be writing down on your paper. Okay? And then we're just going to organize what our variables mean. So the T is going to be your time, okay, in seconds. And remember, that is for the travel of the quarter of a mile. Okay, that's where that comes in, the quarter of the mile. Okay, your W is going to be the weight of the car. Okay, and that's measured in pounds. And then the P is going to be the power of the engine, and that's measured in horsepower. Okay, now if you were doing this exact question on an SAT, then you would probably just plug in your values, okay, and then you would be able to solve using that process. But a really common SAT question is to solve an equation for a different variable, so that's what we're going to do first. So we're going to solve the equation in terms of P. That means instead of having T equals, we want our equation to be P equals. And then for step 3, that's when we're going to evaluate using the given information. Okay, so I'm just going to go over that again. So if you guys were evaluating, you would plug things in and then you would solve, move things to the other side. That would be fine. A common question that you'll see is to solve an equation for a different variable. So that's why we're going to do that part first. Okay? All right, so if I'm solving the equation in terms of P, first I'm going to start with what's given. Okay, and then Lauren, what are you thinking we'd want to do first if we want this equation in terms of P?
We would divide both sides by x1.
Okay, good. And then how did you know to divide?
Because it's multiplied by
Exactly. So make sure you guys are thinking about, oh, these are stuck together with multiplication. If I want to get P by itself, the first thing I have to do is move everything over that's on the outside of the radical before I attempt to get rid of the radical. Okay, so now that those divide to make 1, I have the cube root of W over P. Okay, Kira, what are you thinking? What should we do next? Yep, and what's that going to do? Good. So we're going to cube it to undo the cube root. So I have T over 5.825 cubed. And then this is where you can go in several different directions. What are some of the things you guys are thinking about? Yeah. Lisa.
Multiply by W over W?
That, if you multiply by W over W, let's see what would happen. And tell me why you're thinking that. To both sides?
Yeah.
Well, you have. Well, you wouldn't have to go to both sides.
Well, no, not.
Just this side?
Yeah.
Okay.
Because my thought was then if the W on the bottom would cancel out the one on the top,
Okay.
and then you would have.
But then you'd be left with what?
You'd have P times W, and then you just divide the W.
But if these cancel out, wouldn't you have W over P still?
I did. Okay, never mind. I didn't
Okay.
think that out.
No, that's okay. Yeah, Lauren?
You could have W over T over 5.825 cubed. Like maybe like one of the improper fractions where it's like a fraction on top of.
You're saying putting W over this?
Yes.
And then tell me what algebraic method would get you there.
You would multiply P on both sides, and then you would divide by T over 5.825 cubed.
Okay, yes. So one thing you could do is multiply both sides by P. I'll tell you right now, a very wrong common thing to do is people try to multiply both sides by W, and then they say, oh, the W's cancel, so I just have P. No, you don't. Really, what would you have? you'd have W squared over P, right? Okay, so that's one way that you can do it. Is there another way you guys were thinking? Mm-hmm. Yes, and before I cross multiply, did you do something else? Or how did you cross multiply?
Well, I had I distributed the third one.
Yes.
So it's 2 cubed and then
Yes, and then that cubed. Okay, so those are the two different ways that I am going to show you how to do it. And the reason why I am going to show you both ways, because like I said, this is a common SAT question, and you don't get to write the answer down. You have to be able to recognize multiple forms of an equation. So if you do distribute, I'm going to do one method where I multiply by P, the other method where I distribute. Okay, so if you distribute, you're going to have T cubed, and then we're going to leave this as 5.825 cubed. Can you guys think about why I might leave it like that at this point? Yes, this would be a calculator question, and what Kelsey said is so that you have an exact answer. Yes, because if you do this, if you do 5.825 to the third power, okay, you have this long decimal, and you need to keep this exact. All right, so we're not going to do that yet. All right, so then let's cross multiply. When you cross multiply with the proportion, you would get P times T cubed equals W times 5.825 cubed. Okay, and then Kira, what will be our next step? So we're trying to get it in terms of what? Yep, we're trying to get it in terms of P. So if you cross multiply, right, P times T cubed equals W times 5.825 cubed. So what would I have to do to get P by itself? Yep, and then I can write my final answer for that. So P, one way that we could write this is 5.825 cubed W over T cubed. You could also keep the W in front. Okay, that would be one way that we could recognize that. We are going to keep it exact. And then the other method we talked about would be where you multiply both sides by P. Now, when you do that to get P by itself, you are now going to have to divide. Now, these two equations are equivalent. So your P value here would be W over T over 5.825 cubed. The reason why these are equivalent is if you distributed the cubed, you'd have a fraction, and normally to move over a fraction, what do we do?
Multiply by the denominator.
Yep, or the reciprocal, right? So then that would just flip, and that's why we'd have this. Okay, so these two equations represent the same thing. So when you're evaluating, you can choose either one. Okay, so for the evaluating part, now we're going to use, it tells you you have the 3590 pounds. Well, because I organized this information, I know that that has to be plugged in for W, which is the weight. And then the 13.4 seconds, that's going to be plugged in for T. So now I can just evaluate. Okay, so like I said, you can use either one, but when you're plugging this in, which I do want you to do this, you're going to have to use your parentheses. This would be 13.4 over 5.825, that whole quantity cubed. Okay, you do need to make sure that you are using your parentheses appropriately, and then go ahead and round to the nearest horsepower. Okay, once you get yours, you can check with your group to see if they got the same thing. Okay, and no matter which way you choose, gentlemen,
Not me this time.
okay, so remember, when you're rounding to the nearest whole number, all you do is you look at the tenth, and then that tells you. You can see, because we use the exact value, you do get the same thing for both. So it'd be 295 horsepower. Okay, and then I'll come around just in case you guys need some help with the calculator. And then I want you to do example 3. So think about certain rules that you have with radicals.
It's like the same with all the numbers flying by.
It's just because it's a lot of numbers.
Letters. Area.
I don't like that. It's too many letters. I don't like it.
Don't you love it when the confusion hits you hard? Comes in and delivers.
My opinion.
You're not. No. All right. So I knew this was going to happen. You forgot the things I taught you, and I will go sit in my corner and cry. When you are dealing with the square root, when you have a square root, okay, and these are added underneath, some of you think that it's equivalent to L plus W plus H. Let's prove that it doesn't work. It works if they are multiplied. Okay, so that is why we can take something like the square root of 18 and we can rewrite it as the square root of 9 times 2, because these are multiplied together. But if you have 9 plus 16, what is 9 plus 16?
25.
Okay, so we all agree that the square root of 25 is 5, right? So what you're saying is, if I have addition underneath, then shouldn't these be equal to each other?
They're not.
But they're not, right? The square root of 9 is 3, the square root of 16 is 4, and we know that does not equal 5. Okay, so that means that when you have addition, okay, you cannot break those apart. Remember, we just talked about radicals. Radicals are all about factors. If you're adding them, okay, then you don't have the factors, you have a sum. So how can we undo the root if we're trying to get h by itself? Yes, so we'll start by squaring both sides. So d squared would equal L squared plus W squared plus H squared. Okay, and then Maria, what would I want to do next? So if I'm trying to get H by itself. Yep, so what are you going to subtract? Good, so I'm going to subtract the L squared and I'm going to subtract the W squared. Okay, now let's think about inverses. I have the power of 2. Cole, what's the inverse of a power? Yes. Now, in this case, when you're taking your square root, okay, what do you guys think this D stands for?
Distance.
The distance. Okay, this is the length, the width, and the height. So in this case, when you're writing out your equation, you don't have to worry about your plus or minus here. And your final answer will be h is equivalent to the square root of d squared minus L squared minus W squared. Now, let me tell you, listen, let me tell you a quick little thing you could do on the SAT or on your test or quiz. If you plugged in values for these, okay, and got a certain answer, you should get the same answer when you solve for H here. Okay, so if you said like L was 1, W was 2, H was 3, and you solve that for H, you should get the same value in both of them. So you could just make up random values, plug them in, make sure they're the same. Something like this would be, if it was on your calculator portion, then you could do the square root and compare your decimals. Okay. All right, so I'm going to give you some time to start your homework, and then in a little bit we will do some presentations. Okay, and then tomorrow I will check your 5-8. Okay, so there's your homework.